So in this video I'm going to run through several examples of curve fitting using a sinusoidal graph. And so let's jump right into it. So a pendulum is swinging back and forth. It takes 3 seconds. So let's get a picture of this. Pendulum is swinging back and forth. It takes 3 seconds for the pendulum to swing through a 150-degree angle from the left extreme to the right extreme. So we're saying from there to there, that's 150 degrees. Input is time in seconds, and output is the angle measured in radians. So my t is going to be time in seconds, and my y is going to be angle in radians. So they give us the angle in degrees, but we're supposed to switch that into radians apparently. So now notice this doesn't tell you when you're supposed to start. There's no indication of where we start. So since we're just trying to come up with an equation that that models this, we can let time start where we want. So I'm going to let so I'm going to change my definition of t, and I'm going to say t equals time in seconds since pendulum started at extreme right. Okay. Now the reason why I picked that is because that way I can just use cosine and not have to do any phase shift. So I'm defining what my time is. Time is measured in seconds since pendulum started at extreme right. So that means my graph is going to look like this. Right? And since this whole thing is 150 degrees, which would be what, 5 pi over 6, so that means that the top point is going to be half of that, which would be 5 pi over 12, and this bottom point down here would be negative 5 pi over 12. Right? And so just for that quick little sketch, we should be able to write this. My amplitude is 5 pi over 12 because that's half of the distance. That's half the total distance. We're going to use cosine because I'm starting at the top. My frequency, it takes 3 seconds for the pendulum to swing through a 150-degree angle from the left extreme to the right extreme. So we're going to, that means there's going to be a total of 6 seconds. So this would be 2 pi divided by 6, which would be pi over 3. And we're going to put a time in there. I don't need any phase shift because I'm starting at the right. And I don't need a vertical shift because it's centered on the middle. Because we're also going to define angles and radians where yeah, so it's angle made with a vertical line in the middle. So we're angle and radians with vertical line, and we'll randomly choose right is positive and left is negative. So you can see in this case it left open how we defined our variables, and so we went ahead and defined them in ways that made it easier for us. Now let's say if I would have said the time starts since pendulum started at the middle. So let's say instead of starting at the right and swinging it, we're going to start at the middle and tap it to the right. So then that would change the way this works. So then it would look like this, wouldn't it? So then how would I change this? I'd change that to sine, and I'd be done. Okay, let's do another one. I am thinking of a Ferris wheel that when you are sitting in the cart at the very top, you are 203 feet above ground. Let's draw a picture of that. So that's 203. When you first get in the cart, you're 3 feet above ground. So that's 3. It can do 2 revolutions in 1 minute. 2 revolutions in 1 minute. That means 1 revolution in half a minute. So one revolution is the same thing as period, right? So that means my period is 30 seconds. Right? So let's write this thing, y equals, now you usually get in a Ferris wheel at the bottom, so we're going to let our time start at the bottom when we get in. So that means we want a negative cosine. My amplitude is going to be 100, because the total distance here is 200. Cut that in half, you get 100. So then we'll put a cosine here. My frequency is going to be 2 pi. Frequency is equal to 2 pi over 30, because my period is 30. So that'd be pi over 15. So put pi over 15 in here. Put my time. Don't need a phase shift because I'm starting at the bottom and I put a negative out front. And my middle is going to be 103 because I just shifted up. You can, again, you want to look for the middle of that space. So notice when I plug in 0 here, I get cosine is 1. 1 times a negative 100 is negative 100 plus 103. Gives me that 3 at the starting spot. Okay, moving right along. Tarzan, we did the Tarzan one in the Zoom meeting. So if you weren't there for the Zoom meeting, you should check that out. It's under the Panopto recordings in Canvas. So let's look at this one. Number 5 says, researchers find a creature from an alien planet. Its body temperatures vary sinusoidally with time. 35 minutes after they start timing, it reaches a high of 120 degrees. Okay, so if we draw a quick sketch of that, at 35, it's up here at 120. 20 minutes after that, so that'd be out here at 55, it reaches its next low. So that would be there at 104. So we get a picture of what this thing looks like. So that's its temperature. You can see they told us it varies sinusoidally, so that's why we can draw just a sine or cosine graph. So there's a rough sketch of it. Write an equation expressing temperature in terms of minutes since they started timing. So this is going to come back here somewhere. I don't know when it crosses that, but we do know that it goes from 104? I can't read my own writing. 104 to 120. That's 16 total. So that means the amplitude is going to be 8. I'm going to use cosine because it's easy to find the top. Frequency. So from the maximum to the minimum is a total of 20, is that minutes? Yeah, 20 minutes. And that would be half of a cycle. So we'd have to go another 20 minutes to get the other part of the cycle. So that's 40 minutes. So my frequency is going to be equal to 2 pi divided by 40. So that would be pi over 20 times x. I do need a phase shift here because the maximum, the first maximum that I know of, there's actually probably one before this, but the first maximum I know of is at 35, so I'm going to just make it easy on myself, just go minus 35. And then I just got to find the new middle, so 104 plus 8 would be plus 112. Okay, so I write an equation expressing temperature in terms of minutes since they started timing. So that would be the equation that represents that graph. Now, could I write a different equation? Yes, I could have written negative cosine and then found where the minimum was because it's back here somewhere. Definitely we know the minimum is 20 minutes this way, so it would be at 15, right? So it should hit the bottom at 15 and start going back up. I didn't leave enough room in there, but because we know this would be 20 and that would be 20. In fact, let me fix that. I don't like the way that looks. 35, 15, and it won't quite make it to the top. The top will be over there somewhere, right? Because we know that from the middle, or from the bottom to the top is 20 minutes, and from this bottom to that top would also be 20 minutes. So that actually, that maximum would be back here at -5, wouldn't it? Okay. So now, what was its temperature when they first started timing? That's an interesting question. So when they first started timing, that would be right about here in my graph. So the way I'd find that, that's at time equals 0, isn't it? So I would just go y equals 8 times cosine of pi over 20 times x minus 35. Whoops, not x minus 35. I put 0 in for x, so that would be -35 plus 112. Then I grab my calculator and type into that thing 8 cosine of -35 pi divided by 20. Probably could have reduced that in my head a little bit, but I didn't. And then plus 112. So I get approximately equal to 117.657-ish. Okay, so that would be the temperature. Now let's think about, see if that makes sense. The highest temperature it gets is 120, and we should be getting close to the high temperature here because it happens 5 minutes before that, right? So that sounds like a good answer. And again, why do we plug in 0? Because it's at time equals 0. When they first started timing, the time was 0. Okay, part B says find the first 3 times after they started timing at which the temperature is 120 degrees. Well, now, this one's pretty easy because we know that 120 degrees is the top, the maximum. So we know the first one is at 35 minutes, the first 3 times. So, and we know that the period is 40 minutes. So the next one is going to be 75 minutes. And then the next one after that is going to be 115 minutes. So all I'm doing is just adding 40 each time to get to the next one. Okay? I think we'll do one more here. I think we'll do Mark Twain. So Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, he noticed a dead fish caught on one of the paddles. As the wheel turned, the distance d that the fish was from the water surface was a sinusoidal function. Okay, so we got, here's the d graph, or the d axis. And here's the time axis. And so when his stopwatch read 4 seconds, so out here at 4, the fish was at its highest point, 16. It took another 10 seconds before the fish reached the height again. So out here at 14, it's up here again. So that means it had to go down. I think it goes below water because it's on a paddle wheel, right? Yeah, okay. So we know that it hit 14, or it hit a maximum of 4 and a maximum of 14. We also know, because of the symmetry of sinusoidal curves, that it had to hit the minimum at 9, because that would give me 5 here and 5 there, because those have to be evenly spaced. Okay, and we also know that the minimum is going to occur at -2, because the wheel has an 18-foot diameter. So from top to bottom is 18 feet, so 16 minus 18 would be -2. Okay, so now we're going to write y equals, or d equals, sorry. They said d. That's the height of the fish, or whatever it is. Yeah, the dead fish. Okay, so d equals, again, I'm going to use cosine because it's easy to find the top. And we know, oh, let's think about this for a second. Since this is 5 to the closest minimum this way, this would be 5 to the closest minimum that way. So it's going to hit negative 2 again at negative 1, because that'd be 5 to the left of 4. Okay? So now d equals what? The amplitude would be 9, because it's half of that 18, so that'd be 9. I'm going to use cosine. My period is 10. It takes 10 minutes to go from, is it minutes? No, 10 seconds, sorry. It takes 10 seconds to go from maximum to maximum, so that's, my period is 10 seconds, so my frequency would be 2 pi divided by 10. So that'd be pi over 5 there. And then in here I'm going to have a t, and I need to shift it ahead to there, so that would be minus 4. And we know the middle point would be 9 above negative 2, which would be plus 7. So there's my equation. That equation will find the height of the fish at any point based on where Mark Twain's stopwatch is reading. Okay, so how far above the surface was the point when Mark's stopwatch, when they say point they mean fish, was the stopwatch at 5 seconds. So this is one, they're giving me time, so all I have to do is say d equals 9 cosine of pi over 5 times 5 minus 4 plus 7. So I'll put that in my calculator. 9 cosine, of course 5 minus 4 is 1, so it'll just be cosine of pi divided by 5. And that's 7.28 plus 7. So I get roughly 14.28. So 5 seconds into it, the fish is 14.28 feet above water, because we're thinking of positive d's as above water and negative d's as below water. That makes sense, because we should be getting close to, or we just passed a maximum, we're coming back down, so 5 seconds would be right about there somewhere. So 14.28 seems like a good answer. Now part D. What is the first positive value at which what is the first positive value of time at which the point was at the water surface? Again, when they say point, I mean fish. At the water surface. At that time, was it going into or coming out of the water? Okay, so if we look up at our graph, the first time, now this is a little bit tricky, because at the first time that it's at the surface of water, we don't know if it's, where's my highlighter? We don't know if it's right there or right there, because I wasn't real careful about drawing that. It may have gone below the surface of water before before time was started, or it might have gone just after time started. I wasn't real careful about drawing that. I do know that it hits a minimum at negative 1, but I don't know if, for example, it goes like that, or it goes like the way I had it drawn. We're just not sure. So what we're going to have to do is just solve this equation and see what we get. So what is the first positive value of time at which the fish was at the water surface? So the water surface represents 0. So I'm going to say 0 equals 9 cosine of pi over 5 times x minus 4, or t minus 4, sorry, plus 7. And I'll begin solving that thing. So that would be negative 7 divided by 9. Negative 7 divided by 9. And I'm going to take because negative 7, subtract 7 from both sides, divide by 9. I'm going to go ahead and multiply that pi over 5 through. Okay, so then I need to take the arc cosine to get undo that. So that's going to be second cosine of that answer up there. And I get 2.4619. So then I'm going to add to that 4 pi divided by 5. That's 4.97. And then I'm going to divide that by pi over 5. And I get t is approximately equal to 7.92-ish. Okay, so 7.92-ish looks like that guy right there. So that answer makes sense to me. Now the problem is though, oh no, that might not be a problem. Okay, so that makes sense to me. So if we just want to check and make sure we haven't missed that one there. So if there was one here, I mean there is one here, we know that that one is the same distance from the minimum as this is from the minimum. So let's be clear on that. What I'm saying is, erase some of this gobbledygook. Wherever that thing is, wherever it crosses, this distance to where it crosses is the same as this distance to the minimum. So that distance there has to be the same as that distance there. Okay, because this symmetry of cosine. So if we think about that, we know that, whoops. Oh, that was a bummer. Oh, there we go. Huh. Nice. So we know that this red distance up here is going to be clear 9 minus 7.92. So that distance right there is 1.08. So that means that this distance right here is also 1.08. So that tells us that the fish actually hits the surface of the water at the first time at 0.08 seconds. So this right here is actually the second time that it hits the water. Isn't that interesting? So at that time, so the actual answer we want is this one, the 0.08 seconds. At that time, was it going into or coming out of the water? So at that time, it was coming out, wasn't it? Coming out. The second time it hits the surface of water is right here. That would be 7.92. In that case, it's going in. Again, we can tell these by looking at the graphs. Okay, I think I'll stop there. Hopefully this is helpful.